Hello there, guys. Welcome back to our Orbiter flight series where we departed the Earth. We did a slingshot around Venus, and we have arrived here at Mars. Now, we did have a little bit of a fiasco in the last flight. We damaged our spacecraft, so what we're doing now is we're still in one piece. The crew is alive. The spacecraft, well, you know, it's been in better condition, but we are en route to rendezvous with the fuel service station. That is a space station that's in an orbit roughly about 400 kilometers above the surface of Mars. You can see that our plane is fairly aligned. It slipped off a little bit. Again, we do have our realism settings. Everything's on, so you've got non-spherical gravity sources and things like that. That's going to cause your orbit to be perturbed more than if you don't play with that. So really no surprise there. We are 946 days into the mission so far, and we have plenty of locks on board. Now, what we want to do here is essentially we have to coast around. We do have a rendezvous point set up. I actually don't have Sync MFD opened anymore. Let's do this. Let's go to sync orbit. We're going to target the fuel service station because obviously it's another day since I recorded the last episode. And I apologize, guys, if I was pretty distracted in that episode, but you can see that we do have a rendezvous point set up here at our periapsis. Let's pull up orbit MFD over here on this side. You can see that our periapsis, let me get rid of some of that text there. You can see, in fact, let me grab my drawing tools again because I think that's pretty helpful. And you know, these videos, by the way, guys, I record them quite a while before they're actually published and you see them. So if you do leave me comments, just understand that you know, the next episode that you see, I'm probably not going to really be able to address your comments because it's probably going to be mini episodes until you kind of get caught up to where I'm actually at. But looking at this again, just kind of pointing out, you know, our periapsis is right here. This is our periapsis in our orbit, and that is our rendezvous point. You can see it indicated here on the sync orbit MFD as well. This line right here is basically telling us where the fuel service station is, and this one right here is telling us where we are. So we are both traveling around Mars this direction. So you can see that we are slightly ahead of where the fuel service station is. You can actually see that graphically a little bit better if you go to the map MFD. Let's just go to orbit plane and take a look. You can see, let's track, zoom in. And here we are right here. So we're kind of traveling in this direction, and you can see that the fuel service station here is trailing just behind us. So what we need to do is kind of let the fuel service station catch up to us, and in order to do that, one side of our orbit essentially needs to be higher than the fuel service station, because the higher your orbit is, the slower your velocity is going to be. And you can kind of see that here if we go to maybe a little bit easier to see on the orbit MFD. It's very subtle, but if you look here, you can see that our apoapsis on this side of the planet is a little bit higher than the fuel service stations, right? So as the fuel service station and us kind of work around Mars, like we orbit around Mars this way, our velocity over here on this side of the planet is going to be significantly slower, a little bit slower than the fuel service stations, and that will allow it to catch up to us, and hopefully we have a nice rendezvous over here at our periapsis. Now, it's not going to be super close because we do have DT men here has slid off a little bit. This number right here, this is what we were trying to get to 0. It's slid off a 0 a little bit, and additionally, if we look at our plane, it's not perfectly aligned. It's a little bit off, and when we're talking about rendezvousing the spacecraft, we do want to try to get that as close as we can. All right, enough of me jabbering. Let's go ahead and speed time up. And I think what we can do is, you can see here is our position here, indicated by that P, and you can see how we're kind of traveling this direction around Mars. I think what we'll do is when we get to the descending node here, we'll just do a slight plane change maneuver just to try to lower that relative inclination. At least we can fix that. And then we'll see what we can do with our linear RCS to try to get that DT min number on 0. And hopefully that will improve our rendezvous point just a little bit. So let's go ahead and face prograde. We are at 10 times acceleration. Let me make sure that we have that always displayed. Let's see, where is that? Always show warp factor. Yeah, that's what I want. Perfect. Okay, so we're facing prograde. Let's continue to coast around until we get to this descending node, and we're gonna do a normal burn, I guess, with the plus, and it's probably not gonna take very much. We could, I don't know if it's gonna be a little too much to use linear RCS, I think. So we'll just go ahead and we'll go ahead and point upwards for that burn, and use our main engines just to make sure that we get it done in time. So let's fast forward, get pointed the right direction here, and we can go ahead and turn on that autopilot, and we'll speed time up, watch that time to node counting down. When that gets to about 1 second, we'll do a quick little burn with the main engines. Should not take very much. Here we go. Okay, that was it.
Translation.
Linear RCS. Get that right on 0. All right, now let's let's go ahead and point prograde again, and you'll see that DT min is actually not that bad. So I'm not sure that I really want to mess with changing that. That's pretty darn close. I mean, for all intents purposes, we're gonna have plenty of a close pass by the space station. It should not be a big deal, and we'll actually get fairly close to it. I think it'll still be dark out. If we go ahead and pull up the map MFD and take a look, let's see. Right, so our rendezvous point is going to be kind of right over here, just before orbital sunrise. So we should be able to do the docking procedure just as we're passing into orbital sunrise. So hopefully we should have some daylight, get a nice view of the space station anyways. And yeah, that looks good. All right, so let's go ahead and speed time up. We're going to coast around the night side of Mars here. You can see the glider here on the map. That's at Olympus, the base. So that's one of the places that we've landed at before in a previous series, the flight to Mars. I'll put a card at the top of the video. Be sure and check that out if you guys missed that. I'm sure most of you guys watching have seen that, but that was a fun flight for sure. I think we were pretty much landing on fumes, if I recall correctly. That was a very entertaining flight. Okay, so just continue to speed time up. We are getting fairly close to the space station now. We are about 20 kilometers out, so let's go to normal time speed. I think what we're going to do now is go ahead and get our nav comm set up. Let's go to info. We're going to select the vessel FSSB, and then for nav 1 I think we want to put this on the transponder frequency, so that should be 130.50. There it is. And then for nav 2 we should put this on the docking port. So we're gonna, everything's available, so we'll do docking port number 1. That's 108.05. So probably go this way. 108.05. Oop, there it is. All right. Now I don't know if we're close enough. We actually should be close enough for the docking port. So what we can do is go to docking, and it's on nav 1, so we're close enough for that signal, but let's hit nav 2 and we're close enough for that one. Perfect. All right, and then we can switch our HUD over to, can I just hit HUD? Yeah, perfect. And there's the space station just ahead of us. We have about a 10 meter per second closure velocity. That's not bad at all. That is completely manageable. We are still 20 kilometers out, and let's see, our velocity vector is over here. So our velocity vector is kind of this is telling us where the spacecraft is actually, you know, moving towards, and of course we want it to be moving towards the space station. But what we can do is we can use linear RCS to kind of move that. See, if I translate over to the right, if I kind of use linear RCS to translate to the right, it moves that velocity vector. But I want to just kind of look at this because you can see, obviously, we are closing here on the space station. You'll see that velocity vector is already naturally moving over that direction. And that's because we already had DT min here for our closest pass already set up. It wasn't perfect, so it's not going to really get us all the way over there. We will have to use some linear RCS. But I think it's going to get us, we just want to watch this as long as it's continuing to move in the right direction. Right now there's nothing to do with this. We just want to continue to watch the docking MFD here, make sure that we maintain we are essentially closing in on the space station. You can see our closure velocity here. This is what we want to see. If we see the closure velocity start to come down and go the other direction, then we know that we're beginning to move away from the space station, and that's when we definitely want to start taking action. So right now we are looking pretty good. We are on the night side of the planet. Let's see, where are we? So we're basically right in the middle of the night side over here, and we're 17 kilometers out. So like I said, by the time we actually rendezvous and dock, we should have daylight. So let's get it back over to our docking MFD. We are still closing on the space station, but let's slow time down. We're back to normal time. You'll notice that now the velocity vector, it doesn't appear to be moving over towards the space station anymore. Okay, so what I'm going to start doing is I'm going to use my linear RCS, and I'm just going to force it to move over that direction. Let's make these changes here, and you can just start to see the corridor. This is the docking corridor that's extending out from the space station. We need to be coming in to that docking corridor. So let's just go ahead and continue to translate over here towards the space station and get it so our velocity vector is kind of taking us right over to that docking corridor. All right, now it probably won't stay there. We'll have to kind of fiddle with linear RCS to keep it there. But let's go ahead and point the front of the spacecraft toward the space station there. And again, our closure velocity is nice and manageable here. I mean, we're only talking about 17 meters per second. If I do linear RCS and just kind of translate back, you can see that it's not taking very much translation at all to have an impact on that closure velocity. So this is fantastic. This is what we want. We don't want to have to be messing around with our main engines or our retro engines. If we can just manage our energy with just using linear RCS, then we're in really good shape. So let's speed time up and continue to coast forward. And as you can see, the velocity vector is trying to move away from where we want it. We want it back over here. So as we speed time up, I'm just going to use linear RCS and just kind of try to keep that right over that docking corridor. And we're at 10 times acceleration here, and I'm just going to use the control key just to kind of keep that velocity vector right over the end of that docking corridor where we want to be coming in. As we slowly creep up to the space station, we'll probably have to use it linear RCS a little bit less as we get closer and closer. Okay, we're under 10 kilometers to the space station. I think when we get to about 5 kilometers, which is going to be any moment now, I'm going to go to normal time speed and kind of assess where we are. But you're starting to get your first look at the space station there. And here we go. 5 kilometers out. Okay. Accidentally turned the HUD off. It looks like we are fixing to start getting some daylight. I think I see some daylight shining off of the space station there. Let me check the map, see where we are. No, we are still on the night side, so we got a little bit more to go until we get to orbital sunrise. So I think what we'll do is just kind of slow our closure velocity so we can ensure that we do have daylight, if anything, just so it looks good in the video, guys. But you can certainly dock at night. The spacecraft, of course, has lights on it. Okay, so let's just close or slow down some of this closure velocity. Because what we're going to do is just point the nose right towards that velocity vector. And we're just going to translate back a little bit. Just slow that closure velocity down. You can see it's dropping down 16 meters per second, 15 meters per second. Let's get that down to maybe 10 meters per second, something like that should work. There's 12 meters per second. We're about 4.4 kilometers away from the space station, and there's 10 meters per second. So nice and slow closure velocity there. Okay, now let's go ahead and just continue to time warp ahead. I don't think we need the sync orbit MFD. We've pretty much encountered the space station. And I'm just going to use linear RCS again, just try to keep that velocity vector right out towards the end of the docking corridor.
3,000.
Okay, here we go. We are 2.3 kilometers out, and we should start to see some sun soon. Let me take a look outside the spacecraft. There it is. So we're just starting to see the peak of orbital sunrise. That looks really, really cool. So you'll start to see the space station start to get illuminated here from the sun. That'll make it a little bit easier for us to see it. Check that out. That's always awesome to see. Here comes the sun. Really cool. All right, so you can see the space station starting to get illuminated nicely there from the sun. Let's go ahead and continue to what happened to my docking MFD. There we go. Let's continue to coast forward here. So we have, we did okay on fuel. We did use quite a bit of fuel because we did that burn to slow down, you know, some of that crazy velocity we had. We were coming in over 11,000 meters per second, I believe it was, after our slingshots to get out here to Mars. That's really high velocity. So we scrubbed some of that and attempted to do the aero capture very poorly. But
rotation.
Okay, let's go ahead and face the nose right into that docking corridor. Speed time up a little bit.
1,900. Translation.
Just translate right down inside of that.
800. 700. 600. 500.
Okay. Looking good, guys. So we're just gonna, let's bring it down a little bit so we can slide inside of that corridor. We'll kind of brake and then turn the spacecraft around and face the right direction for docking. And if I recall correctly, docking is always a little bit tricky when you have all the realism settings on. I might have waited a little too late to brake right there. We're going to overshoot the docking corridor. Came in with just a little bit too much velocity. So that's okay. We'll just continue to brake until we zero out our closure velocity here. Getting close. And we probably want to bring it back just a little bit. That'll do it. All right.
Rotation.
Let's rotate the nose around so we can get a sense of where we are. And while we're doing that, we can go ahead and open the nose cone while we're thinking about it. So we don't want to be the dummy who forgets to open the nose cone. Believe me, I have done it. Although the XR2 will very annoyingly let you know that, hey, your nose cone is closed. So, all right. Okay, we can go ahead and turn off the APU. All right, check that out. That looks really cool, guys. Okay, there is the docking corridor. We didn't overshoot it too bad, so we're good. Oops. All right, so we're going to start rotating the spacecraft around. The objective here is to get that X right into the center of the target. And
translation. Rotation. Translation.
Okay, we're just going to kind of work back and forth between rotation and translation. Let's hop over to this view so the MFD is a little bit bigger for you. So again, we kind of, what we want to do is, you see this X right here, we want that X to be right here in the center of the target, and then you see this this plus right here. Let me grab a different color because it's kind of blending in with everything there. So again, this X right here, this is our rotational alignment. So we want that to be right here in the center of the target. So we have to adjust our rotation, you know, bank and yaw and pitching up and down. We have to adjust that to get that X in the center. There's actually a little arrow up here too that has to do with your roll rotation. That needs to be aligned. And then you have this plus right here. So this is our linear RCS. So we're going to just translate up, down, left, and right in order to get that plus right here in the center of the target. So that's really our objectives with this docking MFD. All right. So what we need to do is translate over to the left. And you can see as I do that, we're moving into that docking corridor, and that plus here is moving towards the middle of the target. That's exactly what we want. Now let's go ahead and translate forward a little bit so we get some closure velocity on the space station there. And essentially we're just going to fly right down that docking corridor. The most important thing is the two bars right here. You want to make sure that those are above your spacecraft, okay? And then you have the bottom of the spacecraft coming in this way. So this is the way that you want to be flying into that docking corridor.
Rotation.
Okay, now what we need to do,
Translation.
let me just translate a little bit that way. Now let's go start working on our rotational alignment. So we know we need to rotate, kind of roll a little bit, and we need to yaw. Yawing to the left is going to bring that X over towards the center of the target. Okay, there it is. And then we're going to pitch wrong direction. We're going to pitch up. And bring that X kind of right towards the center there. All right, now as you get that X close to being in the center of the target, you'll notice that now we have this arrow here that has appeared. And this arrow is your roll alignment, right? So let me show you what that looks like. If I roll to the left, you'll see how that arrow moves and turns red. We want the arrow to be white and in the center, right? So we adjust our roll alignment until that gets aligned. And then we adjust our yaw and our pitch to get that X in the center. It's not going to stay perfectly
Translation.
because of that kind of orbital drift from the, the realism settings that we have on. But let's go ahead and focus up here and get this spacecraft aligned and docked. And I'll tell you what, let me move the docking MFD over here so we get just nice view of Mars and everything there.
Rotation. Translation.
So you'll notice that, see how the rotational alignment is kind of slipping. So it kind of gets to be a little bit of a handful as you try to get the spacecraft into the docking corridor here. So we need to translate up, kind of find that sweet spot.
Rotation. Translation.
Okay, I'm just going to translate forward a little bit.
400.
Let's get over 1 meter per second of closure velocity in, just so it's a little bit easier to try to work the alignment here.
Rotation.
So that rotational alignment seems to really be slipping off super, super easy. So that is actually making things a little bit difficult. There we go. Okay, just speed up a little bit more.
Rotation.
Rotational roll alignment looks really good, and it seems like the rotational alignment keeps slipping off to the left and down.
Translation.
So loosen your muscles, don't get too tense doing this. Okay, so I think if we keep this little arrow here towards the center, that gives us an idea of, we're not really drifting one way or the other. So as we kind of try to get that aligned, the arrow's pointing which way we're drifting. So we kind of work the RCS thrusters and just try to keep that right there in the center.
Rotation. Translation.
Rotation's slipping off a little bit there.
Translation. Rotation.
Oops, wrong direction.
200.
Yeah, this is actually pretty hard, guys. When you have those all those realism settings on, it's a handful. So I'm going to get us kind of close and then see if I can get everything stabilized before we go for that last little push into the docking port. Let's just take a quick look outside, make sure, yep, nose cone is opened. Everything looks good. That looks really cool. Last little look outside there before we finish our docking here.
Rotation.
All right, let's see what we can do with rotation. Let's get that centered, and then let's look at the drift on that. I think I need to do that and that.
Translation.
Translation is coming in a little bit over that direction. Oh, I forgot it backwards. Down. Sometimes it helps to pay more attention to the docking corridor than get stuck staring at the MFD.
Rotation. 100.
I like the docking alarm, or the I guess proximity sensor sound effect with the XR sounds. That's pretty cool. I do like that.
75.
Okay, we're getting close.
Rotation. Translation. Rotation.
Roll has slipped off a little bit there.
50. Translation. 40.
Okay, let's start slowing down a little bit. Okay, use the control key to kind of fine tune that.
Rotation 9. 8. 7. Translation 6. 5. Rotation 4. 3. Translation 2.
Looking okay.
1. Contact.
Perfect. There we go. All right, guys.
Ship is docked.
Ship is docked. We have made it to Mars. Let's do some house maintenance here. Let's go ahead and turn off our RCS mode. We can go ahead and power down the MFD. Let's see. Okay, radiator is open. Let's come up here. We can turn off our lights. Let's turn on the APU. We are going to open our doors so the crew can stretch their legs inside the space station for a bit. We can go ahead and we'll leave the radiator deployed, but we can also turn on external cooling. So in terms of locks, we had 151 days left of locks, so we did okay there. We had plenty of locks. Fuel-wise, we had 16.5% remaining in the main tank, 24% in the RCS tank. So, you know, we used most of the fuel to get here, but we did make it, guys. So that is pretty much it. That we completed all of our objectives for this flight. We have made it here safely to the fuel service station, although we do have the damaged spacecraft here, right? So it would be interesting to see if it's possible to land this thing on Mars. So I don't know. I wasn't really planning on doing any other parts in the series, so I don't know yet if I'm going to have time to continue the series from here. If I do, I'll be sure and post in the comments below and let you guys know, because by then obviously I will have it recorded if I'm going to. And I think what we'll do if we do continue the series from here is go ahead and see if we can land this this crippled spacecraft on the surface of Mars. Landing on Mars in itself is always a challenge, so we'll see if we proceed with that. Maybe we'll land on Mars and then maybe there's a crew down there that could repair the spacecraft for us, and then maybe we could see about getting back to Earth. So I don't know yet if I'm going to record those, but again, I will make sure I post in the comments below. If this is the last video of the series, I really appreciate you guys tuning in. Like I said, I'm not necessarily back to making Orbiter videos all the time, but it's something that I still have obviously a passion in, and I'm quite positive I will be making another Orbiter series. There is one, obviously, I know you guys have been left on the hook about. That was the one, gosh, you know, I forgot what it was even called. It's been so long, it's a little embarrassing. But I posted a kind of a upcoming preview of it where you had Mars was colonized, and the Deep Star went missing and was found in a low orbit around Neptune. A very storyline driven orbiter series. That is a project that I definitely want to do. The issue, really, there was a couple of issues. Obviously, I've been very busy in my real life, but the other issue is that the Aero Freighter was the main ship that I was going to use for that mission. And I think most of you guys know that the Aero Freighter isn't really adapted for Orbiter 2016 yet. I think Dan was working on it initially. He might have went dark for a while, but I'm sure he'll get around to finishing work on it. If not, Dimitri has been helping get that Aero Freighter updated for Orbiter 2016. Of course, he can't publish it without permission from Dan, but I'm hoping that either way, we can work something out where we can get the Aero Freighter operable in Orbiter 2016 so that I can record that video series. That is definitely a project that will get done one day. I just don't know when, so I don't really want to make any promises going forward as to when that will be done, but that is definitely a project that I do want to complete. So guys, just kind of zoom out here, get a nice look around. Like I said, I really appreciate you tuning into the series. I hope you guys are all well. Thanks as always for watching, and we will see you in the next video.